I'm going to turn things over to our moderator for this panel on climate change in South Asia, Professor Dan Schrag. Again, I could probably do a full seminar, full hour on each individual speaker, so I'll do just the briefest. And again, you can find their full bios for all of our speakers online, as well as right behind their heads. But again, in brief, Professor Dan Schrag is a good friend and partner of the Institute. He is the Sturgis Super Professor of Geology, Professor of Environmental Science and Engineering, and the co-director of the Science, Technology, and Public Policy program here at Harvard. Professor Dan Schrag, I'll turn it over to you.
Thank you.
Your show.
Nice to see everyone today. So I'm a climate scientist, and I've been working on climate, all aspects of climate from the climate system itself to energy technology and policy for about 30 years. And what is maybe most scary about my experience working on this problem is that every 2 or 3 years, my perception of what is the most worrisome part of the climate problem changes. That's troubling because it tells us how much we still don't understand and how much there is to learn about what our vulnerabilities are to this changing situation. I'm not going to talk about climate science very much in this introduction. I want to talk about South Asia, but let me just very quickly give you a reminder that climate change is a collective action problem because the greenhouse gases that are driving the Earth towards a warmer planet mix in the atmosphere, and therefore what really matters is the cumulative global emissions. That is, it's the integral of all our emissions of the longest lived and dominant greenhouse gas, carbon dioxide, that really set the problem. And it is truly global. It's global, but it's not equal, and we'll talk about this in a minute. And that makes it very difficult. And the second aspect that makes it super hard is that every aspect of climate change pretty much has super long timescales. And humans are really bad at dealing with timescales, and we'll talk about this with respect to South Asia in just a minute as well. It's important that everybody understands that. I want to first, though, make sure everybody realizes the fundamental unfairness of climate change. So this is a figure showing global cumulative emissions of carbon dioxide. So this tells you who in the world has contributed what to what is driving this problem. And this is essentially cumulative emissions from 1750 up to 2021. So it's changed a little bit over the last 3 years. What you can see is that the US is responsible for about a quarter, 25% of the problem. The EU, about 22%. Well, if you include the UK in that. I guess without the UK, it's only 17%. China, 14.5%, but their emissions are so large, they're almost 30% of global emissions, that it's been growing very fast. So in 2017, this figure only had China at 12.5%, and now it's 14.5%, and probably by now, 2024, it's closer to 16%. So they're increasing very rapidly. Now, usually when I talk about this, I talk about Africa and how sub-Saharan Africa, in total, if you exclude South Africa, all the rest of sub-Saharan Africa contributes less than 1% to cumulative global emissions. But let's talk about South Asia. Here's Asia. You can see India with a whopping 3.3% of global cumulative emissions. Bangladesh, 0.1%. And Pakistan with a whopping 0.3%. This is the fundamental unfairness of climate change. I promise you that South Asia will have way more than whatever this adds up to, 3.5%, 3.7% of cumulative global emissions. They will endure more than 3% of the impacts. And that's the fundamental problem, that climate injustice is that most of the people who are affected by climate change did very little to contribute to the problem. And this is true at the inter-country level. It's also true within countries, of course. And so within a country like India or within a country like the US, many of the people who will suffer the most are not necessarily the people who contributed, either they or their ancestors, to those emissions. That's fundamentally unfair, and there's really not a very good pathway to remedying this, unfortunately. There's also another aspect of this injustice, which has to do with intergenerational issues. And again, I remind you that the timescales for this problem are very long. Some of the CO2, about a third of the CO2 that's in the atmosphere from human activities will still be there 20,000 years from now. So we are making decisions today that will affect the Earth, not just for your children or grandchildren, but literally for thousands of generations of humans. And that's very hard to get your head around in a culture that deals with things on timescales of months to maybe a year or two. Long-term planning is 5 years. How do you think about a problem with timescales this long? Not so easy. I want to talk about South Asia very briefly before we turn to our panel, because we have a lot of really interesting things to discuss. But I'm going to start with a picture that may surprise some of you. This is Hurricane Maria that hit the island of Puerto Rico in 2017. The reason for this you'll see in a second. Puerto Rico did incredible damage to Puerto Rico. Here's a picture of just what it looked like in the aftermath. And the chaos and the loss of infrastructure affected people to this day. I was just in Puerto Rico 3 weeks ago, and the island is still traumatized by this. At Harvard, 2 people, including one person sitting in the back here, did something really courageous and heroic. Sachet Balsari and Caroline Bucky, 2 of my dear friends, took a group of students and colleagues down to Puerto Rico after the storm. At the time, the government estimated the official death count at 64 people. And they went down to Puerto Rico and sent people out to do surveys all over the island. And they did a very careful estimate of mortality, estimating it at 4,645 people, obviously with some big uncertainty. But that's almost 100 times bigger than the official government estimate. Now, some of this is not so simple. The official government estimate was based on people who got hit by a tree and died. This included people who might have died a week or 2 later because they didn't have access to their medicines, or a whole variety of other issues. And there's a question of how do you attribute mortality to a weather event, and it's complicated. But this was heroic work and ultimately changed the perception of how this particular disaster affected the island of Puerto Rico. Caroline and Sachet and myself and Jennifer Leaning and a number of other people, my colleague Peter Hybers and Tarun Khanna himself, are part of this cluster now to essentially think about this in the context of South Asia. Asking the question, what kind of vulnerability to climate change exists in South Asia, and how do we think about this going forward in terms of reducing that vulnerability? One component, a big component of what we're thinking about, is of course heat. And this is where I've come to worry about South Asia more than any other region in the world. And I want to just point this out here. This is a headline from the New York Times from 2019. India heat wave soaring up to 123 degrees has killed at least 36. I highlight that with a question mark and 2 exclamation points, because that should sound a little bit like Hurricane Maria in Puerto Rico. Really? This was a heat wave that lasted several weeks. In 2003, a heat wave not even close to this much in Europe, Western Europe, killed 70,000 people, 15,000 people in France. In 2022, a similar but even stronger heat wave in Europe didn't last as long, but it was higher temperatures, probably killed 20 or 30,000 people. So 36 people? Really? In India? When there's so much vulnerability and poverty? Can that possibly be right? I hope you all realize that this is absurd. This is like the official death count after Hurricane Maria in Puerto Rico. And what this team is working on right now is trying to understand what mortality really looks like when there's a heat wave in India, in Bangladesh, in Pakistan. This is really difficult work because mortality is hard to understand. It's hard to calculate. The data are difficult to get and are not necessarily accurate. And Sajid could talk for a long time about the complications. But this is not going to stop. These heat waves are not going to stop. Here's a headline from 2020. India heat wave, Delhi temperature hits 47°C as North India reels. And of course, in 2022, you had a brutal heat wave across India and Pakistan, creating, again, we knew it's deadly, but we're not sure how deadly. About 10 years ago, some colleagues of mine, earth scientists, introduced a rather terrifying concept, which is called the wet bulb temperature. This isn't to say that we already know that heat kills people. We see that in Europe in 2003 or in other situations. But the wet bulb temperature is like an absolute limit to survivability. Wet bulb is basically if you take a thermometer and put a wet cloth around it and let it evaporate, the temperature in the thermometer cools down. So it's essentially combining temperature and humidity. It's taking into account our ability to evaporate and cool. And of course, humans have a natural adaptation to heat, which is we sweat, and that allows us to cool. Dogs don't have that. They pant, and they lose water through their mouths and airway. So the temperature, the wet bulb temperature is always lower than the regular temperature unless the humidity is 100%, and then they're the same. The interesting idea that my colleagues introduced was the idea that when the wet bulb temperature exceeds about 35 degrees Celsius, essentially the body can no longer cool itself. Can't cool itself by evaporation, that's already part of the wet bulb temperature. Can't cool itself by radiating heat because the outside temperature is hotter. And at that point, the internal heat we generate from our food, the internal energy every body generates, just starts to increase body temperature. The scary thing about the wet bulb temperature is when it goes above 35 degrees, even if you're lying inside out in the shade, you will die. Not right away. It might take you a few hours for your body to overheat, but you will die. It's an absolute limit to human survivability. Now, the good news is there's only a handful of places in the world, most of them in the Middle East, where the wet bulb temperatures exceeded 35, and then only for a very brief amount of time. So this isn't where we are today. But as the Earth warms 2, 3, 4 degrees Celsius, there may be broad swaths of the Middle East and South Asia that experience these conditions in a heat wave. We can't quite predict when that will happen, but it's really close to the limit of survivability. This is not just science, it's science fiction as well. This is a book called Ministry for the Future that some of you may have read. This is the opening. It's a heat wave in India that kills 20 million people. That's the opening for this book. In response, the Indian government tries to do some solar geoengineering, which is reflecting sunlight to cool the planet. That's a whole separate discussion I'm not going to get into today, but it's an indication of how terrifying this is. And this is science fiction, at least for now. The problem is that, these kind of heat waves are not going away and will get more intense. And when you look at the model projections for what South Asia will look like in 2070 or 2090, it's not clear how humans can actually live there during these extreme heat waves. And I'm not sure what the world's going to do about that. This is one of the things we've been discussing in our group. Massive migration is certainly an option, but how do you move about 2 billion people from the region? How can you even think about that? It's not tomorrow, but it's terrifying. One crazy idea that I've been playing with is inspired by colleagues of mine who's a photographer. People here might know what these are. These are step wells. These are magical. Some of these are 1,000 years old. Beautiful structures that collect water in the rainy season and are places for people to convene. Some of these are literally like temples underground. Magical things. Beautiful. This is pictures from my colleague Claudio Cambone, who's a wonderful photographer. This is a little crazy. Maybe this is science fiction too, but it's almost like Dune, where people literally have to live underground. But this may be one of the few solutions to survivability in South Asia during the hottest times of the year 100 years from now. Could we imagine this? Well, in some ways, the existence of these structures tell us that this kind of approach is possible, but for the scale of what's required, it's really extraordinary. Tarun actually told me that when he was a kid, they would make them play in the basement when they were little because it was too hot to go outside. Could that be the future for the entire spring in India? I don't know, but this needs to be seriously thought. And I'll say one final thing about timescale before we turn to our panel, who are all working on various components that are directly relevant to this issue. And that is that when I was in Delhi, I guess a year ago, workshop on adaptation to climate change in India and Bangladesh. For them, adaptation to climate change meant thinking about what's going to happen next year. For very understandable reasons, very few people are thinking 50 years out because they have so many big problems tomorrow. Why would anybody think 50 years ahead? And yet, what is coming looks nothing like what they're experiencing today. And that is, I think, a really important role for the Mittal Institute and for a university like Harvard to think, step back and think a little bit longer term and explore not just what the problems are that we're confronting, but also how we're going to manage them. So, with that introduction, I want to just briefly introduce everybody. From left to right, we have Ahmed Shaikh, who's an assistant professor at the Critical Care Institute in Mount Sinai in New York, a place where I got my pediatric care when I was a kid. Not at the Critical Care Institute, but just at Mount Sinai. Then next to him is Francesca Dominici, my colleague and the Clarence James Gamble Professor of Biostatistics, Population and Data Science at the Chan School of Public Health. And finally, Natalie Ayers, who's a research affiliate and data science intern at Crisis Ready and a PhD student in the government department. And I will introduce each of them and bring them into our conversation. You'll see how much they are actively contributing to this dialogue. So we'll have a little conversation, and then we'll widen the conversation to include everybody here in the room. Okay, thank you. Natalie, let's start with you. You're a graduate student, but you've been thinking hard about climate data and thinking about this really from a data science perspective. Want to give us a little perspective on how you're thinking about these challenges?
Yeah, absolutely. And so the work I can talk about today comes from work that I'm doing with Satya Balsari and Caroline Bucky, who you mentioned, and partners at Direct Relief, which is a humanitarian research organization. And they've been working for years on, you mentioned some of their work, we're doing a lot of work in kind of managing active natural disasters. So providing data science-based tools that are actually, that are accurate first, but that are also translatable to the context so that people who are actively working to manage these disasters are able to have the tools they need to target the most vulnerable populations, to identify them, to know what they need. And through that work, kind of managing active disasters, it became very clear to the team that the infrastructure to help prepare to prevent these disasters in the future, or at least mitigate the damage, just doesn't exist in the places that are going to be hardest hit by especially climate-based disasters. So as you mentioned, Southeast Asia, India in particular is one of the first places we're working with, is already being hit extremely hard and will only be more impacted by climate change as the years go on. But the resources and infrastructure to make data-driven decisions to help mitigate those climate impacts do not really exist. Various governments in India are working on this, but really it's not at the pace that is required. So one of the projects, I guess the main project I'll talk about today, is called ClimateVerse, which is essentially an enhanced version of a climate data repository for policymakers, humanitarians, NGOs, to use to help see what's coming, identify vulnerable populations, and make better policy decisions. So in developing this climate-verse repository, and actually Francesca will also be talking about a similar project that her team is working on, and we've been working in collaboration to kind of enhance both of our products. But we started with essentially just a huge round of stakeholder interviews, because one of the things we've noticed is that people bringing technology into under-resourced environments often just kind of bring their own conceptions of what's needed and what technology works in really rich countries like the US, and expect everything to work as it does in kind of their home countries. So we started working with the All India Disaster Mitigation Institute to conduct these stakeholder interviews to really identify kind of the core needs of individuals who are going to be responding to disasters and also planning for disasters in the future. And from those, we identified kind of key data that's needed to answer those questions and solve some of their problems, and also key information that's needed about each of these data sets to actually be able to determine whether they're useful or not. So this is things like, what are the spatial and temporal scales of the data? What are the access restrictions? Things that seem kind of really simple and basic, but often are not available for these kind of data, if the data are available at all. So based on those stakeholder interviews, we designed a set of metadata for data sets that are going to go into this climate repository that really targets kind of the most pressing needs and will enable potential users to make quick and informed decisions. We're also working on a series of data scorecards to kind of combine this metadata into a quick and easy visual representation for easier access. And then we are putting this information into a AI-assisted data repository built off of Dataverse, which was built by Gary King here at Harvard and the Institute for Quantitative Social Sciences. Dataverse is essentially an open source data repository that you can install anywhere on any servers, which is really important to some of, especially the government partners that we'll be working with, to have their own data repository on their own servers in country.
So this is as you obviously have experienced, getting access to these data is really not so easy. So you can build the greatest tool. I mean, one of the ironies is that lack of access to data across this region, I think, has prevented, frankly, a lot of good climate science from being done. If you look at the studies that look at what climate impacts will be using models in South Asia, they're kind of crude because the data model comparisons can't be made because nobody has access to data. And if you're a climate scientist in Europe or in the US and you can't get the data, you give up and you go work somewhere else. And so in some ways, the region suffers from lack of transparency. How do you think that can be fixed?
Yeah, I think so. I think we're hoping to at least start a conversation, and that conversation starts by identifying really what the key issues are. So there's kind of a number of buckets. We've been using this exercise, building our first climate verse with Indian data. We're also working on one in Colombia as well. But we're treating this as an opportunity to really do an evaluation of the state of the climate data ecosystem in India, to really target key areas. So as you mentioned, sometimes this data doesn't even exist to answer the questions that you need. So that's one kind of bucket. Sometimes there are access barriers, and that can be kind of financial barriers or regulatory barriers where you have to write in. It can be also something as simple as kind of the UIs being really unfriendly for users, or data being stored in multiple different silos. It can be things like not having the appropriate documentation of the data to actually know kind of what are the uncertainty and error levels that I need or that come along with this data, so that when I combine it with other data sources, I can actually accurately calculate how correct this data is. There are problems with the data format not being correct. So we've got about a little bit more than 100 data sets in this first climate data repository. And I think it's about 25% are in a kind of format that's not friendly for machines to read. So things like PDFs or Word documents, for example, instead of data tables or kind of spatial data. So yeah, I think it's a big problem, and I think that it's not going to be an easy solution, but starting that conversation is something that we're really hoping that this project will contribute to, and making the problem known.
That's awesome. So Francesca, you've been working on data science for long before data science became
I'm really young.
Cool.
I mean,
you are very young. It tells you how recent the field is.
I mean, data science was invented before I was born. I just want to make sure.
Although the term data science is actually pretty recent.
We could have a fight about that, but that's okay.
But you also direct Harvard's Data Science Institute, and have been a champion of using these data. But your own work really is focused on health-related issues. So when you hear Natalie talk about this, I know you've done a lot of work in this space as well. It's like a daunting problem, isn't it?
Mm-hmm. Yeah. So first of all, I mean, I belong to the fan club of Natalie and Sachet and Caroline, because I think what they're doing is, I would believe, really transformational, because they're doing the hard work on really harmonizing, standardizing, documenting, all of the data, and both on climate exposure and health outcome in the country where it's the hardest to get. And I think they're doing the hard work because what happened is, we can talk about AI and machine learning, whatever you want, but if you don't have the right data to train the machine, instead of artificial intelligence, you get artificial stupidity. So I think I'm really, this is hard work. So I'm really proud of that, and it's my privilege to interact with them. My work, in a certain way, when I think about and when I'm listening to Natalie, it's been in a certain way easier, because most of the data science platform and the algorithm has been analyzing and gathering and harmonizing US data. And so we have, of course, it's much easier. 10 times easier. But on the other hand, I think by doing that is allowing me to understand and appreciate how do you have the highest possible standard into creating this data platform and to building algorithm to analyze this data, so then we can learn and then we can export our experience when you're doing when you're doing the same thing. Because the good news, in a certain way, data is data everywhere around the world, and the challenges with data, and I think right now the biggest challenge, and the good news is that there is a lot of more work, is what Natalie is considering, especially in developing countries, especially in South Asia, with data are, we call it multimodal, right? You have satellite data, you have videos, you have images, and so now we're doing better and better in integrating that. So my work in the United States has been to basically analyze the entire US healthcare system and linking it with environmental exposure to air pollution and other climate stressor, quantifying the health impact, and then directly informing air quality regulation in the US. And so it's been really data science for impact in the US. I am pleased to report that the Biden administration actually passed more stringent national ambient air quality standard for the US last February. That has a very important repercussion in the US and hopefully all around the country, because of all around the world, because by targeting the same sources of air pollution, we're also targeting the same sources of greenhouse gases emission, and we know that the U.S. is extremely responsible for that. And so, just one more thing in terms of my work, the other important piece, I think, when we're thinking and linking actually to what you were saying, then. There are two aspects when you try to link climate and health. There are two things to keep in mind. One, which is how you correctly quantify the health impact of climate change, right? So the classical example of the beautiful work done in Puerto Rico, and still the huge challenges of quantifying number of deaths attributable to heat waves, or tropical cyclone. That is a challenge actually still there. Even in the United States, crazy enough, in the United States, we don't have a standard definition of how we calculate number of deaths attributable to heat waves. It's like, and so there are still, I would say, huge, statistical and data science challenges to even quantify it. And we know that it's important to quantify correctly, because if you quantify correctly, you have a higher chance to inform policy. But then, given in addition to the quantification of the health impact of these climate change events, I think there is the other big bucket of adaptation measures. And that's where actually how do we intervene and how do we adapt to the next heat wave that's going to happen, because we know it's going to happen. That actually can vary. And that's where a situation where actually what we learn in the US is not transferable to what will work in Pakistan. Because the adaptation or mitigation or whatever we do to minimize the number of health events from heat waves really it depends on all a bunch of factors above and beyond of the severity of the heat, right? It depends on how comorbidity, how sick the population is, or whatever factor, access to healthcare, and so on. The good news, and that's the last point I want to make for now, is I think there are good and bad news with respect to the artificial intelligence revolution. So I think let me start with the bad news. The bad news is what we're seeing, especially in places like the US and in China, that I don't think, and there is still no peer-reviewed research on that, but we do know that the explosion of AI is gonna create so much more greenhouse gases emission that we can't even imagine, because it's gonna really empower, need more electricity, and the electricity is gonna come from all the usual sources. So we're gonna see that the AI revolution is gonna, even increase even more greenhouse gases emission from the developing country, because everyone has to do AI. That's the bad news. The good news is I do think, and then we can talk more about that, but I do think that the AI model, and especially now this AI generative model, if Natalie and her team are continuing, and of course many other people are bringing the best possible data, this model can be trained on vast amount of data, and that can actually inform localized intervention for adaptation. So there is actually a possibility if you get to the point where you can get reasonable and unbiased data, you can train this model on this unbiased data, and then you can have, from a machine learning terminology, what I call downstream task, where you can ask if there is the next wave in this town in Pakistan with where the clinic is only, the closest clinic is 20 miles away, what do we do, right? So I see that it's, I think, a very exciting path.
So just following up on that, Francesca, so there's lots, I sometimes feel like when we talk about climate change impact studies, sometimes scientists look for their keys under the light post, right? We look where the data are good, because that's where we can do nice, elegant, statistically significant studies. And we're not looking where the data are difficult.
Yep.
And Natalie's certainly experiencing that now. For example, we see this in Europe, in England and France, after 2003 and between 2022, when they had that second huge heat wave in Europe, the number of air conditioning sales skyrocketed. So you have air conditioners installed across the UK in a way that you never had before 2003.
Yep.
And that's adaptation. Then you go to India, where 10% of households have air conditioning. You just don't have that same capability.
Exactly.
And we have to think about it differently. Or, for example, your beautiful work on particles and air pollution. Dirty places in the US are still 20 times cleaner than average days in Delhi.
Yep.
The air pollution is so bad. Extrapolation of impacts is very challenging, isn't it?
Yeah.
How do you actually think about that when you?
Yeah. I think that, first of all, we are at Harvard, and sometimes I'm thinking that, we have the opportunity also to change what are the priority for the best possible data science. And let me just, brag about that for a moment, or rave about that. We see that, even at the top computer science conference all around the world, they tend to advance research that develop the epsilon better AI algorithm, and less, it's changing a little bit, and less to advance and feature the work that Natalie is doing, right? Because I think I agree with you. There is, you can transfer it, but unless you have the data, we are continuing to be in the same loop, right? And I do think that this is really time. And I have to say, it's changing because the top computer science conference now have a track about the privilege, like people that work on the space that Natalie's working, right? How do you get the best possible data? So, but I think we're still behind that because let's make it clear, right? The best PhD and the best faculty position around the world is because you have the next epsilon better algorithm, and not because you have labeled all of the satellite images in Pakistan and what happened to the next, after the next hurricane, right? Yeah. So I think actually that's really a problem because and that's what I would like to do, if we start changing the way that we support and incentivize career path and, and also instead of, again, a marginal increment of an algorithm you're never going to use versus creating the best possible database. So then this is why I'm frustrated, because then if we have the best possible data, right, not only we in the US can do the best possible analysis for Pakistan, but then we can have the people, and I'm taking Pakistan as an example, we can do capacity building because then we can position the data scientists in this country to analyze this data. Because the other thing that we have to keep in mind is that even if I have, or Natalie has, with all the respect for Natalie, the best possible data for Pakistan, I think that when we're talking about issues of climate, we need to have the Pakistani analyze that data because they understand things that I don't understand. She doesn't understand because we don't live there, right? So that's why I think that, if I had the magic really to create a data platform, which again is just about of career incentives and put the money where they need to be, because there is really not other, I would say, obstacle. There's not technological obstacle now to do that. Then if you have the best possible data, then you can build capacity building, you can train people on the ground to start, which is what I know they're doing, to start analyzing this data. And then that's what's going to change the policy, that's what's going to inform it, that's what's going to forecast. But if we don't overcome that challenge, it still is going to be politics, opinion, things like me saying, this is what's going to happen in Pakistan and not knowing what I'm talking about because I just analyzed it in the US.
Mm-hmm. So I want to bring in Ahmed, who is not working on data science, but is actually generating data. And again, as part of the broad effort that Sachin and Caroline and I and others and Tarun are involved in. Why don't you tell us a little bit about what you're doing on the ground? Because understanding people's relationship to heat is complicated, and let's hear a little bit about that.
Absolutely. So I think the best heat exposure data that we have from a clinical world is reactionary. You get heat exposed, you're hot, heat-related illnesses, stroke, exhaustion, how do we treat that? Our best exposure data is actually from short-term, limited control settings studies that look at short-term exposures to workers in the sugarcane field, military data, athlete data. Doesn't really look at the actual population that is at risk as we deal with more and more heat-related illnesses in the medical field. So, our idea, and then the best data that we have for the current weather station data is sparse across, as Dr. Bolsari mentioned yesterday, at weather stations left at the airports pre-independence, and doesn't capture the microclimates or capture the urban heat islands that exist in some of these.
And just to be clear, by microclimates, what we mean is
homes and work,
like what the temperature is inside the shop where someone's working, or in the house where someone's sleeping, as opposed to what it is out at the airport.
Absolutely, including the context, because a home where or workplace where you're glass blowing is very different from when you're weaving. It's a very different exposure to heat and humidity and sort of and what's the downstream impact of the human physiologic response to that. And you brought up sort of the human physiologic limits to this exposure. But also, before we get to that, what are the limitations before human productivity in a economically disadvantaged daily wage working community? So how do we measure that? And so our idea was to create a dense sensor grid of environmental sensors that measure heat and humidity. Combine that with personal wearables. These devices have gotten, they're the cheapest they've ever been. They're the most ubiquitous. The interfaces are the most user-friendly. They all plug into existing technology, cell phones and Android phones, into a very evolved 4G, 5G network within India. And so what we went ahead with is to deploy, is to plan a deployment of these sensors within these microclimate or these environments, the homes, the habitats, the workplaces, and combine this data and tag this data to personal wearables of the people actually working and living in these homes, in the sleeping quarters, in the working quarters. And to get a little bit technical about what we're using here, we're using Govi sensors, which is sort of a company that designs temperature and humidity sensors, Kestrels, which in addition to that will also capture pressure, and combine that with heart rate variability from the Fitbit, surface temperatures, activity, and all of this through its own proprietary apps goes through one of our own apps designed by one of our team members and brings it to the back end to the Airtable, which is the data infrastructure. We're currently in pilot. We have a few sensors deployed on the ground, and our goal is really to test the infrastructure to see how this data is communicated and how it holds within this.
And what have we learned so far? What is the exposure compared to what these average airport temperatures are? What you see on a meteorological map? What is the experience of an individual worker in living somewhere in?
Yeah. So I think we certainly established that temperature within these environments is much higher than what's being predicted or what's being measured by the weather stations. And I think we're at this time I think we're testing the infrastructure to see that to make sure that all this data actually is appropriately tagged on the back end. And what we're seeing is that there is a difference between weather station data and the local exposure. Mm-hmm. The next steps for us from here would involve ramping up to actually, to a randomized sort of sample of the members of the SEVA community, and ramping up to hopefully 50, hopefully 100 over the next 1 month, with the goal of being up to 720 at 2 years. And combine this with the human physiology piece of it, which is measurement of blood tests and urine samples to test for impacts to kidneys and an impact to, so what is sort of the exposure and dehydration, and urine data to test for sort of urine concentration to see what is the daily, impact and variation, and hopefully have this spaced out as a baseline data. Subsequently, test that against these heat-related events of a major heat wave, and test that against what was the baseline.
Can I ask a question?
Yeah.
So this is fascinating, and I'm wondering is because you have the opportunity to collect personalized data, right? So you mentioned, for example, kidney failure, right? So simple example, in the United States, during the heat wave, actually the highest rate of hospitalization is not even heat stroke, it's kidney failure. So are you envisioning, and I know you are in the pilot phase, but are you envisioning that eventually your app would be able to give personalized recommendation about how to mitigate the effect of heat based on your own blood pressure, based on your own individual level comorbidity and your individual level exposure.
Absolutely. So I think the big piece here is not just necessarily just measuring the data, but it's also adaptation strategies.
Right.
And so the adaptation strategies being environmental, which is focusing on what are the next investments for the environment. How do we mitigate sort of the heat islands, and which includes, say, painting a roof white to reflect heat off, or opening up a little hole in the tin roof to make sure that heat can escape through, or better ventilation strategies. But then from a personal level, absolutely, we certainly envision opportunities to create personalized and dedicated recommendations. Hey, your heart rate is up, and there's your core temperature, and we recommend that you drink some water, or spend some time in the shade, or take a break, or even create some policy changes that daily wage workers in the outdoor space, which involves who are involved with physically intense labor, are required to take a break between, say, noon and 2 p.m. because that's when we're seeing the highest exposure. And by performing this adaptation strategy in a select group of participants, we're demonstrating lesser incidence of kidney failure, or lesser incidence of dehydration, or UTIs and pelvic infections, as Dr. Balsari mentioned.
Yeah.
Natalie, what does this make you think about in terms of how does this resonate with the data you're trying to collect?
Yeah, I think, a lot of thoughts come to mind. And I mean, the potential for this kind of data to be incorporated in, as you were saying, making policy changes, I think is really powerful. Though, figuring out how to navigate the kind of data security issues is kind of, I think, a big task that also Sachet and others on the team are working with. How do we keep personal data safe when we're using it in a much broader sense, I think is something that the community is still really discussing. I think it also just raises a really important challenge with using even the kind of data that we think we have. I think, one of the starkest things for me to come out, you've already mentioned it, but just to really highlight it, is that data that we think we're getting from satellites that we think is accurate, which we don't even have everywhere. So we think we're very lucky to be having it, but really doesn't necessarily reflect the temperatures on the ground. So how do we navigate? We want to collect we want to have as much data as possible for making these kind of decisions. And satellite imagery and other kind of remote sensing and sensor data seems like one of the most plausible means to expand that. But if it's really producing such skewed results, how do we kind of navigate that as data professionals going in and wanting to use it?
I think that and I think just listening to both of you, that's really the perfect opportunity, I'm thinking, to integrate, because in one hand, you're exactly right that his sensor data is probably more precise and accurate than we get from the satellite. But the good news is that we don't need to have a measurement on that for everybody. Even if we have a sample, hopefully we can have a representative sample. You can correct the bias, right? And then you can account for that. So I think that this is where I think data science platform and getting data where, I guess, it's the perfect, beautiful example of personalized data, but then you have challenges in scaling it to everybody, and you have challenges with the security issue. But by doing your work and then doing it more granular level, we can understand what are the biases that come from the more general day level, and then, take account for that and adjust and figure out the degree to which intervention at the population level need to be rethought for some specific situation. So that's why I think that's a classical example of the work that you are doing and how you integrate it, that there is really, I think, a tremendous amount of opportunity.
Yeah, and I think it'll be
do something great. Yeah,
it'll be fascinating to see when your kind of project is able to be scaled out to other communities, other countries,
right?
Like where different biases are coming from, because I imagine
you guys have to work together.
Yeah. That's right.
Understanding the relationship.
Good.
Right.
Understanding the relationship to large-scale temperature patterns, to specific experiences of individuals within a community.
Yep.
And that's going to obviously vary between countries and between even regions within a country. We have only about 12, 15 minutes left. And so I wanted to bring in the audience a little bit. So I see a question over here first. There's a microphone somewhere, isn't there? There was a handheld mic.
Speak loud.
I think there was one here somewhere. Oh, there it is. Good. Thank you. Please.
If you might humor me a little bit in a thought experiment. So I was recently in Thailand, and farmers burn agriculture in Myanmar and Thailand, and from the refuse. They're trying to change that in some way, regulatory in Thailand, Myanmar not. And the combination of that and the diesel fuel of tourism, manufacturing, buses, trains, et cetera, is overwhelming pollution. There were even government warnings out. So this is about changing farmer behavior. It's about your example of how this is affecting at the populace level. I wasn't really thinking about the data aspect, but so much of it is about data and communicating that data to government officials and across the ecosystem. So if you would humor me, and if coming from each of your backgrounds, how you might tackle this overwhelming, and I know I was at the World Bank for Transforming Transportation following my Thailand trip, and I asked this question when they were talking about alternative airline fuels, and somebody at the World Bank was really excited by my question because he had been in India and similar issues, and there are people that are working on that, alternative fuels and farmers and changing farmer behavior, incentivizing, but it's so complicated. So anyway, if anybody would humor me and try to tackle how you would go about an intervention. Yeah.
Anybody want to jump in on that?
Maybe let me get the start. I mean, first of all, it's really hard. By no means I can claim I have a solution, but I think that there will be at least two essential components to think about. One is, again, to inform the government official with sound data, so then they can change regulation, whatever is the fuel of the way that are fueling their buses, and so there has to be a governmental action to pass some regulation. Plus, has to be coupled, and I actually think is the hardest one, with the behavioral change and the community level change, because you can have whatever law that you want, but it's clear, and again, by no means with my maximum level of humility, I cannot even possibly imagine what is every day on this population, but the reality is they are doing what they're doing and they are exposed to all of these environmental contaminants. Why? Because they don't have any alternative, right? So I think that this is why these problems are really hard, that you have to go hand in hand with the government changing some laws, so then doing certain things is not allowed, together with a community level intervention that you enable people to be, to eat and drink and have the sustainable livelihood, but they will not require burning things or cooking inside the home or not having access to safe measure for public health.
So one
Sorry? The innovators have to be in it. Of course, yes.
So one of the challenges, the good news is that for the biomass burning part, globally, we are making progress on that. The total amount of biomass burning is declining every year and is substantially reduced. It doesn't mean it's not a huge problem in some places, but we have made enormous progress, and that's something that can be worked on. On the diesel fuel side, much more difficult, because we don't yet have alternative technologies for heavy transportation, and they're coming slowly. Now, EVs are moving forward, but it's going to be a while. Somebody here will probably know a lot more about the exact legalities of it, but over a decade ago, the Supreme Court in India ruled that all of the buses in Delhi had to be natural gas, and it didn't happen. Essentially, it was ignored. Air pollution in Delhi is still terrible, And so, even the government policies and legal structures doesn't necessarily solve a problem if there's not a good technological solution. And so this requires technological innovation. It requires economies of scale to bring those costs of those technologies down. And it requires government policies. And it's a hard problem. Let's get some other questions if we have. Yes, here, please.
Thank you so much for sharing all these insights. So coming from Pakistan, I think one of the biggest challenges that we have is around capacity building, and that's something that you brought up. And since we had a change in government as well, so that sort of brings in an added layer of complexity. So my question, I think we have great examples in the region for us to look up to. India is doing great, and there's a lot that I think we share in terms of bureaucratic structures, etc., to learn from. So my question, I think Natalie, maybe you can answer, but just trying to understand at this point, what sort of challenges did you face when you were trying to work at more grassroots level with these organizations in your study, and how did you overcome that, or what still serves as one of the biggest challenges as you and your teams putting together this database for further research? And also, I guess in terms of scalability, it's also very important to understand how do you break through those bureaucratic structures to really do something that leaves a long-lasting impact. Thank you.
Yeah, that's a great question. And I think, we're still working through a lot of these challenges. I think we're just starting in conversations with a few governments, partners for some Indian states. And we've been working with groups like SEWA and AIDMI, who really have kind of the on-the-ground perspective and the capacity and the will to kind of start taking this forward. So kind of our next steps are going to be actually training individuals who are within these organizations to both train them in the tools, so in the data repository, so that they can continue to build it up themselves. But I think equally important, more important maybe, is training in the use of kind of data analytics, and also making sure we get to a point of allowing individuals in these trainings to actually develop tools that will be useful to them in their day-to-day life. Because I think you're absolutely right that the kind of sustainability of this and scalability going along with that, but that's going to be the biggest challenge. There's been so many kind of grand plans for tools and technologies that just aren't adopted and aren't sustainable. So the approach we're taking is working with partners that we already have, or that are already, at least to start, that are already working towards improving their data capacity, kind of introducing this tool, but really working with them to put it in context that's useful to them, to help them start solving problems that are important to them. So we're providing kind of technical guidance, but they're driving what the problems are and what potential solutions are with some of the experience that we've gained. And then the plan is that they will then take on the role of owning these data repositories and using them and adding to them. And that by building tools actually as the end product of these trainings, it will demonstrate the value of them and the value of maintaining. And then we have a number of partners in the region. And so the scalability plan is kind of just to continue moving across partners and help.
Do you have any evidence that this will actually work? I mean, it sounds very ambitious to sort of create these data sets and then say local people will build these tools and use them.
Yeah.
Like, really?
No, yeah, exactly. I think and that's something that we're talking about a lot. I think Sachet and Caroline are kind of experts in translational data, right? Which is like not just throwing data at people and expecting them to use it, but it's a constant challenge. So the way that we're approaching it right now is that we've got a few tools that we've developed for use in disaster contexts, and we know that they're helpful to people working on the ground. And so our plans are to kind of help individuals in these governments build out tools that we know work for their own contexts and tailored to their own problems. And we're hoping that in combination with kind of our continued presence and their continued use of the tool will help maintain it. But yeah, we don't have evidence for this. I think it's really hard to kind of, going back to kind of behavioral interventions, to change things. And if it's not something that's useful for them, it won't be adopted. So yeah, I think working with communities is going to be the key.
I think we have time for maybe just one more question. Go ahead, down here in the front.
Yeah, so thank you for these really good presentations. I'm Hilton. I'm a PhD student in public policy, and I just wanted to ask about the use of data for forecasting, and I'm kind of interested just in the ways that you think of problems of uncertainty. And I mean, we have all kinds of data sets that we use to predict things from stock markets to the weather. And so I'm wondering sort of how uncertainty would play a role in the specific context of India when thinking about prevention systems. And I'm thinking even when we had, I mean, I think this last year at Harvard, we had a snow day that turned out not to be a snow day, and it sort of interrupted a lot of the work that we were actually doing on campus because we were expecting all this snow, and then suddenly we couldn't come onto campus, and then it just turned out to be a lot of rain. So I'm just interested to hear sort of your thoughts on how data can be used in this way, but also what are the potential pitfalls with thinking about it in the context of heating in India.
So let me first just tell you that the analogy to predicting snow accumulation here in Cambridge is a really bad one. And the reason is that there's something called a phase transition, which goes from ice to water. And that means that, and it turns out that the snow-rain line almost always sits very close to the Charles River, a little bit north, a little bit south. And so on any given snowstorm, poor weather forecasters, what we really want to know is how much snow is going to fall in Cambridge. And it turns out that a small change, almost an imperceptible change in that temperature front means the difference between 3 feet of snow in Cambridge and a whole bunch of rain. And it's really hard to predict that. Heat in India or Pakistan or Bangladesh is a very different thing. You don't have the same phase change. There are other issues to deal with in terms of ocean temperatures and things like that, but it's not quite as hard a problem as that. But maybe you want to talk about
I mean, I think, yeah, I mean, maybe I can just very, very, very briefly, I mean, from the data science and statistics viewpoint, right? And that's what I was mentioning, that is important to have with the satellite images, the sensor on the ground, and to really get a sense of the amount of uncertainty and similar thing, both in validation, but also in forecasting how much uncertainty this model are gonna have. And then you need to propagate that. I mean, so there are a couple of things. One is try to minimize the uncertainty as much as possible by having the best possible data on the ground. If you can, try to quantify how much uncertainty you have. So then when you're making conclusion, you're propagating the amount of uncertainty that you have. I mean, that's a challenge.
I'll say there's another aspect of the important work that Ahmed is working on, which is really, really fundamental, which is understanding the environment that people actually experience as opposed to the broad brush temperature or humidity that people measure by satellite or at a weather station, is so fundamental, not just for, as Francesca said, it's really important to understand what you might call biases. Really, it's just different microenvironments and therefore what the real impact of a heat wave of X temperature really is in terms of what people experience. But it's not just that. It also points to modes of intervention, really important modes of adaptation that are critical. And we have to end our panel now, but let me end, I hope, with a hopeful story. It's kind of a horrible story, but I want to point people to the cyclone that hit Bangladesh in 1991. This was one of the worst natural disasters I can imagine. A terrible cyclone in 1991 hit Bangladesh, killed over 138,000 people. 138,000 people. And that's not hopeful at all. That's horrific. What is hopeful is that in 1994, almost the exact same cyclone hit Bangladesh. It was very similar track, same landfall, same intensity, and something like 600 or 700 people died. Now, it was a terrible thing that 600 or 700 people died, but it wasn't 138,000 people, and it was almost the same storm. What happened? Well, most of the difference, I think, can be attributed to two things. One is the government invested in early warning systems. So people knew that the storm was coming, whereas they didn't know in 1991. And that was huge. But the second thing was the government built a whole bunch of very low-tech concrete bunkers. Not expensive. The government of Bangladesh didn't have a lot of money to spend on it. But they built very low-tech shelters, and people used them, and mortality was unbelievably different. So I think the important lesson for me is that some of these interventions are low-tech, not expensive, and really simple, but we can't even imagine what those could be if we don't kind of have the measurements and observations of what people are actually experiencing. And that's why this is so important. Anyway, let me thank all three of our panelists. Please join me. And this discussion of South Asia will continue.
Can I mention one thing? Then I want to call something to light with that Bangladeshi cyclone. That is perhaps the origin of why we are South Asia, not India. In the sense that the undergraduate and graduate student response after that cyclone was unified South Asia at Harvard. And it was amazing because it led to the first ever Gunguru show, which is now one of the university's largest cultural programs. It was in direct response to that, and that continued up till today. And that's why most universities have India centers. It was that cyclone that directly led to this one being South Asia.
Thank you for pointing that out.
Thank you. Thank you all. Thank you, Dan, also. Is this on? Thank you all. Thank you, Dan, also. And that is Mukesh Prasad. He's a member of our advisory board, a Harvard alum, and he was part of that effort in that cyclone era. So thank you, Mukesh. While our next speakers are getting seated, I just wanted to have two of our friends come down for a special little extra surprise, which is really important, and it connects with what we've been talking about. Usman Wahid and John Tain. Usman is a close friend of both myself and of the Institute for a long time. He's a Harvard alum. John is also a Harvard alum. Usman and John are responsible, between the two of them, for the Lahore Biennale. Usman is one of the founders, and John is now the senior curator. And this year's Lahore Biennale is all about climate change. They're just going to take 2 or 3 minutes to tell you what they're doing.
Thank you, Hitesh. Thank you so much for this opportunity. Hello, everyone. My name is Usman Wahid. I was an undergraduate here a little over 30 years ago. I'm from Lahore in Pakistan, and I moved back to Lahore immediately after graduating. In 2016, with a group of friends, we founded a nonprofit in the arts called the Lahore Biennale Foundation. And the idea behind this foundation was really to explore the power of the arts as an agent for social change, as an agent for impact. So our first project in 2016 was a project with the Venice Biennale in Italy that questioned the notions of borders. So the idea was really to use art to address and hopefully heal some of the fissures that we in South Asia know so well. And our first attempt was this project called My East is Your West. And it was an artist project involving Shilpa Gupta from India and Rashid Rana from Lahore in Pakistan. After this, we held the first Lahore Biennale itself, which explored the same theme a little more deeply. And we had, to everybody's surprise, certainly to our surprise, over 100,000 people visiting the biennial in the space of 4 weeks. In 2020, we had the second edition of the Lahore Biennale, which explored the theme of solidarity in the global South. It was titled Between the Sun and the Moon, and it was curated by Hur Al-Qasimi. And in October this year, and this is an open invitation to everybody in this room, from 5th October 2024 till 10th November, we'll be hosting the third Lahore Biennale. And it'll be hosted by a Harvard gentleman to my left, class of '96, John Tain. John heads research at the Asia Art Archives. And the theme of this edition of the Lahore Biennale is actually climate change. So I'll hand it over to John, who can explain a little bit more.
Yeah, thank you, Osman. So, we've been the last hour hearing, the guests speaking about climate change in the South Asian context. And when I was invited to curate the Lahore Biennale, it was also very much thinking about this question of climate crisis, especially as it was in the wake of the 2022 floods that took place in Pakistan and devastated much of the country, killing thousands and also displacing hundreds of thousands. And for us at the Biennale, it was really how, number one, did it make sense to do a Biennale in the wake of that? And number two, if it did make sense, how could an art exhibition help contribute to improving things and making sure that things like that, situations like that, do not happen again? And I think that one thing an art exhibition can do is let people know about the situation, but I think that the news also does that very well. And part of what the Lahore Biennale will be doing is thinking not just about letting people know about the effects of climate crisis, but also about and how it is disproportionately affecting not just South Asia, but Asia overall. I think that the data that was shared at the beginning of the panel made that clear, but also that one of the things that we should do is think about the larger context in which all of this is happening. And for this, I'm taking inspiration from the setting of the Biennale itself, which is the city of Lahore, which of course has thousands of years of history. And so in some ways, if we want to adopt the vocabulary of our previous guests, it offers itself as a kind of large data set of how people have been adapting to climate in the region over the past centuries, if not millennia. And what we can see in the architecture and the crafts traditions of the region is that people have been adapting to the vagaries and unpredictabilities and extremes of the monsoon cycle, which includes drought, which includes flooding, which includes extreme heat. Obviously not in the same extent that we're looking at in the near future, but definitely something that has been happening. So that, one of the things that people aren't necessarily aware of is that, when the Mughals were building these wonders like Shalimar Gardens with its thousands of fountains, all powered by pressure and gravity, this was a moment when South Asia was experiencing centuries of drought, right? And so all of these things, in other words, are what we consider heritage is also evidence of adaptation and of certain technological approaches to thinking about adaptation and resilience. And so what the artists, the 60 plus artists who are invited to participate in the Biennale will be doing is highlighting the way that the culture and art of the region and in South Asia and Asia more generally can be thought of as resources for helping us in the present thinking about how to adapt to the future. So connecting the past and the present with the future. And in addition to the exhibition, there will also be a climate congress, which is precisely about making sure that the voices of South Asia and Asia more generally are heard and are part of the larger conversation about climate crisis and adapting and resilience. So I hope that you can all make it, either for at some point during the Biennale from October, which runs from October through November, or for the Climate Congress, which runs November 2nd to November 8th, and will feature, eminent scholars such as Amitav Ghosh or Sunil Amrit, inviting, fingers crossed, as well as emerging scholars and artists and others, and also how, a selection of art institutions, because part of it is also getting the information that's wonderful information that's being shared in a room like this out to the larger public so that we can really think about how to affect the change that needs to happen and to get the public on board with it. So thank you.
Thank you. Thank you. Thank you both very much, John Tain, Usman Wahid. Thank you.